So let's go ahead and proceed with the next crash. It's a stop 7F, or an unexpected kernel mode trap. Once again, let's go ahead and bring up the debugger. And we'll go ahead and load up the crash dump, choosing demo 3, and it quickly fills up the debugger. So at this point we can see that it is a bug check 7F, and it's also pointed out several modules that it could not load the symbols for, namely AVTAR, SIS, IPS driver, and the filter driver. So already we may have some suspects right here, but we'll go ahead and do the bang analyze-v to get our analysis rolling. I highly encourage you to read the online help associated with this type of crash. A lot of information has gone scrolling by, so let's go ahead and come back to the beginning where we issued that command. Here it is. Bang analyze-v tells us it is an unexpected kernel mode trap, means a trap occurred in kernel mode, and that it's the kind of trap that isn't allowed to have a bound trap, or one that is always instant death, i.e. a double fault. It asks us to look at the first number in the bug check parameters. If it's an 8, that means it's a double fault. So if we look at the exceptions, yes, indeed, it was a double fault, as we can see. This means that while it was trying to handle a fault, an exception that came up, it encountered another one. And anytime it encounters a second one, a double fault, that is instant death, and so we crash the system. So the most typical cause, as you'll find out in the online help for a 7F type bug check, is a stack overflow. For some reason, the stack kept growing and growing until we ran out of kernel stack space. Now it gives you some advice here that if the KV, or the stack command, shows us a task gate on the stack, then we should use the TSS command. And that's exactly what happens here. There is a TSS, a task gate on the stack, so we're going to go ahead and hit that TSS. And what that does is it tells us about all the registers that were current for that thread at the time. And the register of interest is this ESP, which is the stack pointer. As you can see, it's a very high number ending in 3APPLE000. Now, what we might want to do to confirm it was a stack overflow is to look at the actual thread that was executing at the time. So remember that stack pointer, it was ending in 3APPLE1000. If we were to look at the thread and take a look at the thread's stack, the base started at D1000, but because the stack grows backwards, you can see that it had reached the limit of the stack at 3APPLE1000. So yes, indeed, we did run out of stack space. So what we want to do next is to take a look at the driver, or the stack that was executing at the time. And so I did the KB command, and it went on forever and ever and ever. If I were to scroll back, we can see here that I executed the command right here, where I did the KB command, and it showed me the stack that it was trying to allocate pool with tag, but before then it was doing a whole bunch of other stuff, namely in this SIS IPS file filter driver. So if we start reading the stack from the bottom up, let's get an idea of what it's doing. It was running in this AVTAR program, and that essentially handed off control to the kernel, which is the NT bang. Then it brought in the filter manager, which started executing this SIS IPS file filter. And you can see that it's executing this driver quite frequently. This is the corresponding SIS IPS driver, not the filter, but just the regular driver. Notice that offset at offset 13 F as in Fox 9.5. Now, if we scroll up looking at the stack, we could see that same offset within that driver. So it appears to be recursively executing these functions. And lo and behold, if we go up even further, we can see there it is again. So it keeps executing the same series of functions within that driver. And that's what is causing us to run out of stack space. There it is again at the SIS IPS driver plus 13Fox95. It keeps executing the same piece of code again and again and again. And then ultimately, there it is again. We finally, after a lot of executing, we essentially run out of stack space. And so, for some reason, we've got a problem with this driver. We don't know much about this driver, but that is the culprit essentially. The file filter driver and its cousin right there, this other driver. So we can do things like do a bang LMI to get more information on that driver and the other driver associated with it. And that would give us some more information to go search the internet, whether it's bing.com, because this is a third-party driver. We would want to see if there's any known issues with this third-party driver that may cause a stack overflow, or whether there's a newer, updated version of this driver available to potentially fix this problem. So, in summary, this was a 7F bug check caused by a stack overflow. When we looked at the stack, we could see the same driver executing the same bunch of code over and over again until we ran out of kernel stack space. So hopefully this gives you a good idea of how to tackle a stop 7F bug check.